Hi everyone, and welcome to our lesson on polynomial long and synthetic division with the rational root and factor theorems. We're going to talk about two types of division that we can use for our polynomial expressions, and then we're going to move into some strategies we can use when we start solving for the zeros of those functions. So the first type that we're going to talk about is the polynomial long division. So when we see that two polynomials need to be multiplied, one method is the long division, and it's the same as the old numbers long division problems. We're going to set it up, we're going to start the process of dividing, multiplying, subtracting, and carry down your next term. So we're going to see that first thing. So here are two polynomials that we need to divide. And just like we would a normal long division problem, we're going to set up the bar and put in our divisor and our dividend. And now that I'm here, I want to make sure you know when you're dealing with polynomials, you want to make sure that the powers do not skip over any numbers. It needs to be in standard form and no gaps. So you can see that our expression here is missing the x term. So anytime that happens, you can fill in with a 0 for that term. And that will happen a lot. Our x minus 2 is fine. It goes from 1 to none, so we're fine. All right, so we can start our process now. First thing we're going to do is we're going to take a look at our first term on each expression, and we're going to divide. 3x cubed divided by x gives me 3x squared. That's because 3x squared times x takes me back to 3x cubed. So what I'm doing now is I'm going to multiply that top term that I found, 3x squared, by x and then by negative 2. So 3x squared by negative 2 gives me negative 6x squared. And just as in regular long division, now you want to come and subtract the whole expression. So these two should always go away, the first things that you did. And now we have 4x squared plus 6x squared, which is going to give us 10x squared. Drop down our next term and we're ready to go again. Alright, so 10x squared divided by x, my first term in the expression out here, will be 10x. Okay, 10x times x gives me back to 10x squared. 10x times negative 2 is negative 20x. I'm just multiplying that by both things outside again. And I'm going to subtract the whole expression. So I've got 0x minus negative 20x, which is positive 20x. And I'm going to bring down my last term. Do it one more time. So I have 20x divided by x, which is 20. 20 times x is 20x. You should always end up with the same thing there. Remember, they're going to cancel out. And then 20 times negative 2, negative 40. And subtracting the whole thing, these will go away, and I've got 5 plus 40, which is 45. Now, if you end up with a number other than 0, you have a remainder. So what you want to do with that is write it over your outside expression. So here would be your long-term division of polynomials. Now another method that we're going to take a look at is called synthetic division for dividing polynomials. And the way that we're going to do that is we're going to take our expression that needed to be divided. Remember, it was 3x cubed plus 4x squared plus 5 divided by x minus 2. And we're going to sort of create an upside down division bar and list in our coefficient numbers on the top row here. We need to do the same thing we did last time, filling in a 0 for any terms that are missing in order in standard form. And then instead of writing the factor on the outside of the bar, we're going to write the root that would come out of that factor, which is positive 2. If I were to set x minus 2 equal to 0 to find that root, or 0, x would equal 2. So that's what we want to put on the outside there. So synthetic division is just a process of multiplying and adding down each column until you reach the end. I'm going to show you that process. The first step is to bring your front number down below the bar. And then you're going to take your outside number and begin multiplying. 2 by 3 gives me 6, and I'm going to put that number back above the bar. Okay. Then I'm going to add down the column. 4 plus 6 gives me 10. I'm going to come back out and start again and multiply 2 by 10. That gives me 20. Ready to add down the column. 0 plus 20 is also 20. 2 times 20 gives me 40. And adding down this column gives me 45. This is the same expression, so we should end with the same answer that we did using long division. You should be able to get to the same answer either way, and you can. So if you notice, these numbers look familiar because these are the coefficients of the shortened polynomial that we found in our long division process. And what you're going to do when you use synthetic division is you're going to start filling in your variables starting with 1 power less. So ours was a cube, so we're going to start with x squared. And our 10 is going to have an x, and our 20 is going to have no x's. And remember, 45 was our remainder, so we're still going to write that over the factor, x minus 2. So we have the same answer. That's a good sign. That means both processes led us to the correct answer. Alright, one thing to note about synthetic division is that if the number you end on is a 0, that is your clue that the number you tested is a 0 or a root. Our number was 45, so that means that the number we tested outside the bar is not a 0. We have to end on this spot here with a 0 in order for that number to be a root. Alright, we're going to move on to the theorems that help us find our zeros. One of these is the factor theorem, and it just simply says if I substitute a value into my polynomial and I get a 0, then x minus that number is a factor of that polynomial. So I've got one here and I've got a number for us to try. If we want to figure out if 2 is a 0, what we would do is we would plug that in for each x value here. Okay, I'm just going to substitute that in, so we're going to test. We're going to have 2 cubed plus 2. We need our 2 here for that x. Minus 5 times 2 minus 6. So let's follow the right order of operations. So we've got powers first. 8 plus 2 times 2 squared is going to give me 4. Minus, I can go ahead and do this product. 5 times 2 minus 6. 8 plus 8 minus 10 minus 6. Actually going to give us 16 minus 16, which is 0, which by the factor theorem means that x minus the number we tested is a factor. So that'll be good to know later when you're trying to break these down and put them on a graph and continue to solve for those zeros. Alright, so we discussed that x minus 2 is a factor, and anything that you go ahead and test in that polynomial in the same way and end on a 0, you can write the same way. X minus that number will be a factor. Alright, another theorem that's useful for helping us shorten our list of possible zeros is called the rational root theorem. And what that says is that when you're looking at a polynomial in standard form, if you will look at the factors of the constant term divided by the factors of the leading coefficient, then you can create a list that is all the possibilities for your rational roots, and they will not come from any other numbers besides those numbers. So it helps you shorten your work a little bit. We're going to take a look using this example here. Our constant term is 8, and our leading coefficient is 2. So first on top I need the factors of the constant term. So things that 8 can be divided by evenly would be plus or minus 1. Everything can be divided by 1, 2, 4, and 8. I believe that's all. And then on the bottom, in the denominator, we need the factors of 2. That's just going to be 1 and 2. And now to create our list from these fractions, we're going to take every top number over every bottom number. So my possibilities for roots are 1, and then 2, all of the top numbers, 1, 2, 4, and 8. Everything over 1 is still itself. And then 1 over 2 is 1/2. 4 over 2 is 2. We've already listed that one, so we don't have to list it again. And then 8 over 2 is 4. Again, we've already listed that one in our list, so we don't have to list that one again. So when I'm going to test for roots of my polynomial here, I will use this list first to narrow down my selection, and I can go do synthetic division or maybe factoring to continue and find those. This concludes our lesson on polynomial long and synthetic division with the rational root and factor theorems.